All right, this is the last lesson in this unit. We're going to go ahead and graph the sine function and then cosine and then the tangents and then the reciprocals. So we always start with the original function like sine. So for the period for sine is normally 2 pi. So we take 2 pi, we divide by 4, so the unit is pi over 2. So that's why I've decided to count by pi over 2 here. So 0, sine of 0, 0, sine of pi over 2 is 1, sine of pi is 0, -1, and 0, right? Now, if we are graphing the cosecant, that is 1 divided by the sine. So 1 divided by 0 is undefined. So the cosecant is undefined at 0. Cosecant of pi over 2, the reciprocal of 1 is just 1. Same for -1, it's just -1. And these zeros are undefined. All right, so we'll go ahead over here and we'll just graph the sine function. And usually we do that. Usually what I do is I graph the points very lightly with my pencil. And if you choose to, I don't, but if you choose to, with your pencil, you can very lightly, when you want to erase it later, go in and draw the sine graph, okay? But I don't do that, okay? But you can, just so you can get a visual. I usually just leave the points. Now, all you've got to do next is wherever the sine was 0, those become undefined. So here is going to be an asymptote. Here's an asymptote. And here's an asymptote. And now the graph just approaches the asymptotes. And those values we know stay the same, 1 and -1, as we saw. And that's it. So at that point, you would just erase, if you drew the sine graph, you would just go ahead and erase it. All right, let's try cosine. Okay, so 1, 0, -1, 0, and 1. So that's going to be 1. This is undefined. This is -1. Okay. Undefined, 1 over 0, and 1. Okay, so my original points for the cosine graph, and if I wanted to connect them, I could, would be 1, 0, -1, 0, and then back up to 1. There's 1 full period. Okay, so the graph would look like this, right? That's cosine. Okay, but now we are actually not graphing cosine. We are graphing the secant, which is the reciprocal of cosine. So where the original cosine function was 0 is going to be undefined. So we can go ahead and draw asymptotes there. And then from there, you can add in more asymptotes, but usually I just make sure when I draw my graph that it is approaching. Why is that not working? There we go. I don't know why it changed color on me. It's approaching the asymptotes. Okay, what are we doing next? Practicing. Okay, so first, whenever you get an equation or you're asked to graph, for instance, cosecant, you rewrite that original equation with its reciprocal and go ahead and get the points for that first. So I rewrote the equation with the sine instead of cosecant. Now we're just going to do what we've done for the last couple classes and fill in the graph for all the information, and then we're going to switch it at the end. So the amplitude is 1. The period is pi, which makes the unit pi over 4. So we're counting by pi over 4. Okay. We've got a vertical shift of 2. We've got a phase shift of 2, set the parentheses equal to 0, right? So if I solve that, I get negative pi over 4. There's my x, there's my y. So I'm going to go ahead and move my 0, 0. Left pi over 4 and up 2. So there it is. And let me put a little circle around it in purple. Why is that not working? There we go. Okay, now I'm graphing sine. And we've got an amplitude of 1, but we have a reflection, right? So it's going to go low first. So it's going to go low, 0, high, 0, low, 0, high, 0. And I'll do a couple on the other side too. Okay, now if you'd like, you can connect that very, very lightly with a pencil. I am not. I am going to use yellow, and everywhere along my new x-axis, okay, which is we've already drawn on there, I'm going to change anywhere the zeros to asymptotes. So here's one. Here's one. So you see, we're taking the period and we're just breaking it in half whenever we graph these reciprocals. So from there, you're just drawing your graphs. These are super messy, but you get the point. Now your domain is everywhere there's no asymptote. Now we have twice as many asymptotes. So we have to pick one and say x can't be that asymptote. In this case, I'm picking pi over 4 because it's the first one after the y-axis. Plus, now the entire period is cut in half. So to get to the next asymptote, it's half the period times k. In this case, the period is pi, so it's plus pi over 2 times k. And that's your domain. For the range, it has been separated, so we're going to have to do two intervals in union with each other. So negative infinity up to and including that negative 1, right? So negative 1 in union with 3 to infinity. That's the range. All right, let's move on to secant. So first we will graph the cosine. So we go ahead, amplitude is 2, period is the same, 2 pi, which makes the unit pi over 2. Vertical shift is negative 1. Go ahead and draw on your new x-axis. The phase shift, it looks like, is positive 3 pi over 2, because I'm just setting that parentheses equal to 0, so I know it has to be positive plus, right? So here's my x, here's my y. Let's go ahead and put in our new 0, 0, counting by pi over 2. So we're going to the right 1, 2, 3, and then down 1. So there's my new 0, 0. Now, that point is not on the graph because we are graphing cosine, right? So, am I in the right place? Okay, yes. Okay, so from there, I have to find my high point, which is right above this new 0, 0, which is, the amplitude is 2, so we're going to go 2 up. So there we go. And then from there, we're doing high, 0, low, 0, high, 0, and then on the other side, and here's our new 0, 0, so I'll circle it. Okay, go ahead if you'd like and very lightly pencil the sketch in. I am not. I'm just going to change all my zeros to asymptotes. And then just draw the graph in. Well, that's it. The domain for this one is, now notice we started at 0. So the first one would have to be pi, but then you're adding another pi to it. So instead of doing pi plus pi k, I'm going to write x can't be pi k. It's not wrong to write pi plus pi k, but it doesn't matter what k is, so you can just put pi k. You might have to have that explained to you again. So that's the domain, I think, is the most difficult concept for most people. Negative infinity up to and including negative 3, union with 1 to infinity. Hope that's right. All right, try the U-try. Press pause, take a look at it. I'm not going to go over it just because I want to make sure I get to the last ones, which is tangent. Okay, All right, so if you're graphing cotangent, you're going to again start with tangent. So tangent of 0 is 0, tangent of pi over 4 is 1, tangent of pi over 2 is undefined. Is that sine over cosine? And that's where cosine is 0. Denominator can't be 0. So now in 3 pi over 4, we're in quadrant 2, right? So that's negative 1, and then this is 0. Now, take those numbers, and if you flip them, this is 0 over 1. That becomes 1 over 0. This is undefined. So there we go. So your zeros will now be undefined. Oh my gosh. Okay. And your ones will stay ones. Same with your negative ones. Now, your undefined will actually, where it's originally 1 over 0, will become 0 over 1. So your asymptotes will become your new zeros. So let me go ahead and just plot the points for the tangent. This can get a little confusing sometimes because things switch around, but with a little practice, you should be okay. So let's see, 0, 0. I'm just graphing the points for the tangent first. Pi over 4, 1. Pi over 2, undefined. So I'm going to very lightly in green put my asymptote because that's going to change, right? And then 3 pi over 4 is negative 1, and then pi is 0. So what's happening is the graph looks like this, okay? Now, I'm not going to draw that in because we are not graphing the tangent, we're graphing the cotangent. So in a different color, what's going to happen is the zeros, right, those values are going to become your asymptotes. So those are your new asymptotes. Let me draw those in. Oh gosh, why did that happen? Okay, those are your new asymptotes for your graph. And the 0, or the other asymptote, is now going to become 0. So let me go ahead and put that in. The other 2 points stay the same. So we've got that point stays the same, that point stays the same, and now we're graphing in purple. Let me try that again. Okay, so it looks like a negative tangent graph. So just, here's a hint. Yeah, do not connect the dots for the tangent. Just use them in the graph for cotangent. All right, let's see if we can't do this example together. This might be the last one I have time for. So first thing you do, rewrite it as tangent. Amplitude is 2. The period is normally pi. So this is pi divided by 2 because b is 2, which makes the unit pi over 8. Write that on your graph. Phase shift, set the parentheses equal to 0 and solve. There's your new x. Vertical shift is at the end, y. So there's your new 0, 0. Counting by pi over 8, 1 pi over 8, 2 pi over 8, and then down 1. So there's your new 0, 0. So now, all right, so in green, my asymptotes are going to become zeros. So normally, oh, thought I was in green. If I were to go ahead and graph the tangent points that I have there, that would be the asymptotes. But those values are going to change, right? Because we are graphing cotangent. So, and here's our new x-axis. So that's going to become a 0. And look over here. There, that's 0, right? And the 0 is going to become undefined. So now we have a pretty good foundation for our graph here. Normally the next thing I like to do is draw in a few more asymptotes just so I have an idea about what the graph looks like, some boundaries. So 1, 2, 3, 4. 1, 2, 3, 4. And I decide 1, 2, 3, 4. Okay, and again, you can go ahead and set the parentheses equal to pi over 2 when you're doing tangent, you can do that. Cotangent would be, let's not get into that. That would be the opposite. Okay, so where am I at? So now all we have to do is connect the points. So we've got, and we didn't really draw too many points here, but remember the amplitude is 2. So from there, you are just connecting points. All right, I hope I didn't confuse you too much with that problem. All right, try the last one, and I'll show you the answers right here, and our class is over right now. Peace out.